All right, on to part two. So we just did an example with an MM1 spreadsheet, MM1 single server queue implemented in a spreadsheet. And so now let's take a look at what we do for an MM2. So in MM2, the arrival processes are exactly the same as in an MM1, and the service processes per server are the same as in an MM1, but we now have two servers. And so there's some dispatching policy where a customer arrives and then is either dispatched to a server 1, who we can call Able, or server 2, who we can call Baker. And the dispatching policy we're using here is if both servers are available, we're going to prioritize and give the customer to Able first. We need that, especially for the very beginning of the simulation, because at the very beginning of the simulation, both servers will be available. But most of the time, there's only going to be one server available unless there's a lot of idle time. So you can think of these as call center representatives, and these are a telephone line coming in. And so that's the example that they give in this bank example here. So a phone call comes in, and if Able's available, immediately gets the phone call. Otherwise, Baker's gets it. If neither are available, then somebody sits in a hold queue until one of them is available. All right, so we can do this in a spreadsheet just as well. It looks very similar to the MM1 case. How do we end up making these two servers work? Well, let's take a look. Again, we put all the information we know, all the activities we populate ahead of time. So these you can think of as these enter arrival times. These are just drawn from an exponential distribution. These service times can be drawn from an exponential distribution as well. The arrival time 0 and Able and Baker are both available, so we put their available time both at 0. Everything else we have to fill out as we go. So the arrival time, it doesn't change. It's the same formula as in the MM1 case. We just take the previous arrival time and we add to it the inter-arrival time for this particular customer. So how long did this customer wait in between the previous customer? So we can end up populating that whole column there. And then we basically need to figure out which server is going to be chosen per customer. So the server, so this is going to be a little funny seeing this put together in pieces, but this relationship we can at least write out. And remember, I'm showing you kind of what things look like when everything's done. So this calculation isn't ready to be completed, even though the whole column is immediately populated. So basically, the way this rule is you basically say, well, let's look at when the server is available. And based on when they're available, if Able's available time is earlier or the same as Baker's, then we're going to choose Able. Otherwise, we're going to choose Baker. You can implement this in an Excel cell just with an if statement. You can say if this cell is less than or equal to this cell, then put Able here. Otherwise, put Baker here. And so the point is we need to put that rule there, and then we're going to populate these things, and once all of these things get populated, then these things will automatically get calculated as needed. All right, so then we need to figure out the time that the service begins. Well, just like before, it's going to be whatever comes later, the arrival time of the customer, or the time in which a server is available. Now, before we only had one server to worry about. Well, now we have two servers to worry about. So in that little spot where we had the time that the single server was ready, now we have the minimum of whoever's available. So is Able available first or is Baker available first? And so whoever's available first, their time goes in here, and then we take whatever's later, the arrival time of the customer or the time when a server is available, and that will go in the time service begins. So then now we can figure out completion time. So we're getting closer and closer to being able to figure out this gap here, which is a really important gap. But strangely enough, we can keep calculating down this way, and then we'll be able to fill this relationship in once we get there. So when did Able complete its service? Well, we look at Able and we say, well, for Able's completion time, we say when did Able's service begin, and then what was the service, and that's if Able was chosen. Otherwise, if Baker was chosen, since we're in the able column, we just pass along Baker's information. So, so we'll see this, but basically to simplify the calculations, even in customers that are handled by able, we're going to carry along Baker information in the row. And even in customers that are handled by Baker, we're going to carry along able information in the row. And that allows every row just to refer to the previous row. So we don't have to say, based on a certain row, look back several rows to see when able was last used, because we're kind of constantly just carrying that with us so that we only have to look back to one row. It just simplifies the implementation. So able's completion time, that's this column. It depends on when did service begin for this customer. And if able was chosen, then we add the service time. But if we're looking at, say, a Baker call or a Baker row, we're saying, well, okay, so this customer's service might have began at 1, but it was handled by Baker, and we are really trying to figure out when able is done. And so it doesn't really matter to us whether this customer arrived here and how long it took. So this customer, we're just going to take, when Baker is chosen, then for able's completion time, we just carry the completion time down. We just copy it down because it's not really valid for this calculation, because this calculation in this whole row is all about Baker. So we're just going to copy able down, because not because able is useful for the Baker calculation, but because able's number will be useful for later calculations. So, so that's what's happened here. For this customer, able was chosen. And so since able was chosen, then we did time service begins plus the service time to give us when able is available. For this customer, able's availability doesn't change, so we just copy it down. Now, this customer was handled by Baker. So for this customer, we say for this customer, they began their service at 1. The service time lasted 4, and that must have been done by Baker. So now Baker is going to be available when this service time ends, and so Baker's ending service time is here, and then we can fill those down. So then now we finally can go back and say, when are each one of these servers available? And so that's easy. You just look at the previous completion time. So if in this row here, I'm saying when is able available? Well, if I look at the previous completion time, I calculated that able would be available at time 4. And so that's when able is going to be available at time 4. Similarly for Baker, when is Baker available? Well, the previous completion time for Baker is implicitly 0. And so we're saying that Baker is available. Baker's available right now. So that's why customer 2, when they arrive, can immediately get serviced by Baker, because of Baker's available now. And then that goes on down through. So you notice this column looks a lot like this column. It's just kind of a a shifted version. 4477, 4477, 5588, 5588. It's just this column shifted down by 1. So then what's the delay? Well, that's just the time the service begins minus the arrival time. That's how long they waited in the hold queue. And then the response time, the time in system, well, this gets a little more complicated because we have to keep track of who was chosen. And so we can say, well, if this customer was handled by able, then we're going to say, when will able complete this customer? When will able complete next? And when did this customer arrive? And so able's next completion will be when this customer is out, because this customer was handled by able. And so able's next completion minus the arrival time will be the response time for this customer, because this customer was handled by able. If this customer was handled by Baker, then it's going to be Baker's next completion time minus the arrival time. And that ends up giving us the response time for all the customers. So it's possible for us to simulate even an MM2 queue in a simple spreadsheet like this. But as we'll eventually see, it's going to be much easier to deal with this stuff in Arena, where you can just sort of draw out a diagram similar to the one that I showed you here, where basically in Arena, you'll draw this and just say go, and it'll handle everything for you, rather than you having to figure out all the relationships yourself. All right, so another quick stop here for questions and an attendance exercise. So head back to the Canvas questions and answer a small set of questions for this part.